It's November 12th, and this morning at 8 a.m., I awoke in Indianapolis to frost covering my deck, grass, and cars. It was cold out at a temperature of 25 degrees Fahrenheit, but no precipitation was expected for today. So how could this be? Well, it has to do with the properties of the atmosphere, more specifically with dew point and humidity.
So what is relative humidity, and how is it related to dew point? Relative humidity is the amount of moisture in the air versus the amount the air can hold that is invisible to the human eye. Humidity, however, should not be mistaken for precipitation, as special circumstances lead to that. A simpler definition for relative humidity is how close the air is to being saturated. In this example, these cups are halfway full, correlating to 50% relative humidity. If you would take one and pour it into the other, they would be saturated, which means that the relative humidity would now be 100%. At 100% relative humidity, dew point is reached.
Dew point is the temperature at which the air must be cooled for it to become saturated. At this saturation, that is when precipitation, such as dew, fog, and condensation occur. The dew can be seen in this video as it is the white coating of the grass. So now that we know a little bit more about relative humidity and dew point, how can we find these values? Yesterday, the values that were reported at 8 a.m. by the Weather Channel were 78% for relative humidity and 19 degrees Fahrenheit for dew point. But how do they use these numbers in order to find these values? Relative humidity is the vapor pressure in the atmosphere denoted by E divided by the saturation vapor pressure denoted by ES times 100. The equation to solve for vapor pressure and saturated vapor pressure is relatively simple. To solve for both, it uses the same equation. It is 611 e to the 17.27 times t over 237.3 plus t. However, vapor pressure is solved using the dew point temperature, while saturated vapor pressure is solved using current outdoor temperature in Celsius. So now that we know these equations, let's use them to understand our situation. So what do we know? The outside temperature is 25 degrees Fahrenheit or 3.89 Celsius. Dew point temperature is 19 degrees Fahrenheit or negative 7.22 Celsius. The relative humidity is 78%. So let's solve. Saturation vapor pressure is solved using the outside temperature. This value comes out to be 458.186 pascals. The vapor pressure is solved using the dew point temperature, coming out to be 355.369 pascals. And then the relative humidity is solved using the vapor pressure over saturation vapor pressure, which we get 77.56%, which rounds up to the relative humidity, and that is how you solve for relative humidity. The relationship between dew point temperature and air temperature can be seen in this graph. As the dew point temperature and the air temperature are closer together, the relative humidity increases. When the dew point temperature is relatively high, the air will have more moisture in the atmosphere, making it feel more humid even if the relative humidity is low. Explains a little bit how the outside temperature and the dew point are used to solve for relative humidity. What happens when the outside temperature matches the dew point? Well, that's how you get precipitation, and when the dew point is below freezing, that's how you get frost on your car, like so.